This video lesson is the fourth of a series on solving logarithmic equations. We're just going to solve one really tough example of logarithmic equation that can be given on a homework assignment or even a test. Here's the example. Natural log of x plus 2 natural log of x plus 2 equals natural log of 3x plus 6. Alright, so the first step, as usual, is that we want to make it so that there's only one logarithm on each side of the equation. So first, the problem is we have a 2 ln of x plus 2. We fix this by making it the natural log of x plus 2 squared, which is allowed. It's one of the properties of logs. And this whole expression is equal to ln of 3x plus 6. Next, we use the log multiplication rule. So I get natural log of x times x plus 2 squared equals to 3x plus 6. Alright, so the first step is done. We only have one log on each side of the equation. So now all we have to do is look on what's on the inside of these logs. Alright, so this tells us that x times x plus 2 squared equals 3 times x plus 6. Now here is where many people might make a mistake. You do not want to FOIL out and multiply out both sides of the equation yet. Because, look, the right side of the equation is 3 times x plus 2. So we can simplify everything just by dividing by x plus 2. Also notice that dividing by the x plus 2 on both sides is allowed because we can divide anytime we're not dividing by 0. If we're dividing by 0, that is, if dividing by x plus 2 means we're dividing by 0, that means that x would have to be negative 2. But we can't plug in negative 2 in our original expression. Because if we plug in negative 2, we'll have a natural log of 0, which is not allowed. So this means that we can divide by x plus 2, and our answer will not change at all. But that detail isn't that important. Just remember, if you can simplify without having to multiply out, always do it. So now we're just going to continue on. We divide by x plus 2 on both sides. One side goes away completely, and on the other side the square goes away. So what expression do we have now? We have x times x plus 2 equals 3. Well, hey, it's a quadratic equation. Just look. All we need to do is distribute the x, and we'll have our x squared term. So we get x squared plus 2x is equal to 3. So we can rewrite it as x squared plus 2x minus 3 equals 0. Now we just factor, and if you want to learn more about factorizing quadratic equations, then look at the video lesson with that title. And we get that x squared plus 2x minus 3 is equal to x minus 1 times x plus 3. This gives us two possible answers. X equals 1 or x equals negative 3. This is just how we go about solving a quadratic equation. Alright, so we have two answers, but we need to make sure they both work. So let's plug them both in. So we start with x equals 1, let's say. So we take natural log of 1 plus 2 natural log of 3 equals natural log of Well, 3 times 1 plus 6 is 3 plus 6 is 9, so we get natural log of 9. Now remember that the logarithm of 1, no matter the base, is always 0. And then we have 2 natural log of 3 is equal to log of 9. And now we just have to remember the properties of logs. We get 2 ln of 3 is actually ln of 3 squared. And 3 squared is 9. So we get ln of 9 equals ln of 9 is true. So x equals 1 definitely works. What happens if we plug in x equals negative 3? If we plug in negative 3, then we get natural log of negative 3 plus 2 natural log of negative 1 equals natural log of 3 times negative 3 is 9, negative 9 that is, and then we add 6 and we get negative 3. So we get ln of negative 3 plus 2 ln of negative 1 equals ln of negative 3. But each and every single one of these logarithms has a negative number in it. And you can never take the natural log or any other logarithm of a negative. So really, this expression is meaningless. You can't say it's equal, you can't say it's unequal, because you really just, those aren't numbers. You can't take those logarithms. So of course, that possible answer is eliminated. That means the only possibility is x equals 1. And that is our solution. Thank you for watching this video lesson. I hope it helped.